Okay, so now we are going to make use of what we have learned in the revision video, and then we will apply it to different MCQ and structure question. So the video will be recorded every 2 pages, so you can reference to the right video very quickly. So the very basic of kinematics is, of course, the speed or the velocity formula. So as you can see here, in this question you are being asked, the total distance between these two towns is 210 kilometer. You have an average speed of 700 kilometer. Now what does this mean is that basically average speed has a formula. So the formula for average speed is your total distance divided by your total time. So since we are talking about distance, we will not be talking about direction or anything like that. It is a scalar. So what happens is that this total distance is referring to from here like that. So even though it is curved and whatsoever, the total distance is will not get affected. Okay, so how long does the journey take? So how long means that you want to find the time. So if you do your math properly, then you will be able to see that your time basically is equals to your distance over your speed. So since the distance is given, this 210 kilometer is your distance, you will have 210 over here, and then your speed will be 70. So when you you don't even need your calculator. So once you know that, then how long will it take? It will take 210 over 70 as indicated on this side. Some of the misconception that you may have is that some of you may be wondering, how about velocity? Okay, velocity is given by displacement over time, and displacement is the shortest distance. That means you take your final position and you directly minus your initial position. So if you are interested in finding displacement, it will be represented by this line, and then the question will be very different. So just be careful. If you are talking about distance will be the length that the train cover. This curved line will give you the distance. Okay, for your question 2, you are given another question about speed, time and distance. So this time round you are given a speed of 2 meter per second. You know the distance is 8 meter, and you are asked to find how long. So this how long does not refer to distance. This how long refer to the time. So I think this is like a primary school question. Just remember the formula. Speed is equals to distance over time. The speed in this case will be 2, distance is 8. You are supposed to find the time. So if you do your math correctly, you will get this, and you will get 4 seconds. Okay, for question 3, this time round is slightly different. You are given the speed time graph. So if you recall, earlier on when we do revision, okay, your speed time graph has several things that you need to remember. Number 1 is that the gradient of your speed time graph is given by acceleration. Then the area of your speed time graph will give you the distance. So let's see what do the question wants here. So you have a cyclist cycling along the road, and then there's an animal. So all these thing is about the context. The main thing you may want to take note here is that there will be a brake at Q. That means it's slowing down. So braking basically means that it is slowing down. And then basically your cyclist will stop at R. So as you can see here from your speed time graph, between P and Q, he's traveling at, how would you describe this motion? How will you describe this? An adjective and a noun, right? So a noun could be a speed. So this is what we call constant speed, because the speed does not change between P and Q. Or if you want to describe it in terms of acceleration, since it is constant speed, it means that there is no acceleration. So this is what we call zero acceleration. Yeah. So as I'm going through the MCQ, I would also ask you to do other things to check your understanding on other matters. Okay, so how about between Q and R? How would you describe motion between Q and R? So between Q and R, you can see that the speed is dropping because you started off with something that's high and then you end up with zero speed. So Q and L, how would we describe its motion? Well, the speed is definitely dropping, so we say that this is decreasing speed. Simple as that. Yeah, and then we need to talk about acceleration as well, right? So when we talk about acceleration, like I said, you just need to ask yourself, how is the gradient? So if you look at this QR line from Q to R, the gradient is constant, right? Because it is a straight line. So we say that this acceleration is also constant. Now what is interesting is that the gradient between Q and R is also negative. So in another word, this acceleration is negative as well. So just add in the adjective, it is constant and it is negative acceleration. For those who are better, you can even convert it to constant deceleration. Okay, so depending on how you want to study, you can either remember it as constant negative acceleration or constant deceleration because it is slowing down. Okay, so now let's come back to the MCQ question. So now this question is asking you, how would you find the distance after he applied the brake? So it is very important for you to actually take note when is the question focusing on. So in this case, the brake is being applied at Q, and then after that, the whole journey ends at R. So if you want to find the distance after he brakes, you have to find the area under this region, QR. Okay, so this shaded region in blue will give you the distance. So as you can see here, gradient will be wrong because if you want to find gradient, you are getting acceleration. The area is correct, and I have to find the correct area, which is under QR. So the answer is B. Okay, for question 4, it is again a speed time graph, as you can see from the axis. And again, they are asking you to find how far, meaning the distance between this duration 0 to 5. So how do you find distance on a VT graph? Can you recall? How do you find distance in a speed time graph? Is it the gradient or is it the area? So yes, it is the area, and to find this area, it will become this shaded region. So if you look at this shaded region, you can see that the line and the area under it represent this triangle, and you can see that the height here would be 10 because I read from here, and then you can also read the base. It is actually 5 units. So to find your area of triangle will be a half base times height. So it will be half times 5 times 10. That will give you 25. So that's how you find the answer. Okay, the next question is again about speed time graph, as you can see from the axis. This time around, they are asking you about how far. So again, it is the distance. Okay, and this time around, the duration that you are looking for is 50 seconds. So basically, you are looking for this entire duration. What is the distance traveled? Okay, so to find this, you can see that actually the area occupied under the VT graph, under the speed time graph, okay, they are the same. VT graph and speed time graph for your particular syllabus is about the same. Okay, so actually this area represents a trapezium. There are two ways you can find it. You can find it by two steps. You can find the area of triangle first, then after that you add it to this area of rectangle. For me, I will just use the formula directly. So the bottom parallel base is 50 below. The top one would be 30. The height is 20. So if now I want to find the area of a trapezium, basically I can make use of this formula. If you have forgotten this formula, like I said at the beginning, you can separate the area into a triangle and a rectangle. So for me, I remember the formula, so I will just use it directly. So I will get the answer as 800, which is C. Okay, let's look at question 6. So your teacher is very kind. She basically compiled all the similar question to in sequence so that you get to practice it continuously. For me, I would say that this is very basic. You may after you do the next question, you may forget what you did previously. So after this revision exercise, this revision worksheet, I strongly recommend you to try some yearly paper, because then you will have all the knowledge mixed up Okay, if not, you would expect, oh, okay, question 6 is like question 5, question 7 is like question 6. So after this revision, please go and try some yearly paper. So again, this is a speed time graph. So the question is again asking you to find distance. So I'm not going to bore you. Basically, you have to find the area underneath. You just need to be focusing on when or the duration that this question is interested in. So I have to find the distance, but this time round I won't only want the distance when it is moving at steady speed. So what is mean by steady speed? Steady speed means that the speed is constant. So if you look at your speed time graph from 0, t equals to 0 to t equals to 20, you can see that your speed is rising. So this rising speed does not mean that the speed is constant. If you look at 20 to 40, you can see that the speed is remaining at 10. So this is what we call a steady speed, or what we call a constant speed. From 40 to 50, okay, 40 to 50, you can see that the speed is dropping. So again, we are not referring to this region. So if you look at question 6, they are only interested in finding the distance when the object is traveling at steady speed, meaning that I only interested in finding this rectangle. So if you look at this rectangle, the base, it will be 20, and then after that the height will be 10. So you will get the answer as C, 200.